So in my last class, we are discussing about that different types of discussing about the different types of drives, especially DC drives, and what are the basic operations for the speed control by using the power electronics converters for DC drives. Okay, so today we are going to discuss about different mode of operations. Okay, what do you mean by different modes of operation? So I told you that in when we are using when we are working with the traction drives. Okay, so that motor should capable. Okay, motor should capable to operate in motoring conditions. Okay, as well as braking conditions. So different so normally motoring conditions that we all are know about it. So about the braking conditions. Okay, so I hope you are aware about the different quadrant operations of the machines, different quadrant operations of the motor. Okay, so different quadrant operations means suppose your speed torque characteristics, if we are able to draw it. Okay, or we are able to plot that value speed torque characteristics. Normally what we are considering t omega. Okay, so both are positive means we can say like that they are in motoring conditions. Okay, as per your convention. Okay, suppose you are considering that clockwise rotations may be the motoring conditions and anti-clockwise rotations is your generating conditions. Okay, for that positive configuration you can say like that as per your conventions. Okay, so what value you are considering, so it's up to you. Okay, and based on that reference you can define is it your motoring mode or it is your braking mode. Okay, braking mode means it may be dynamic braking, it may be regenerative braking, it may be plugging. Okay, so only their zone of operations in different quadrant. Okay, so suppose motoring mode in your first quadrant, then in case of regenerative braking will be in your second quadrant. Okay, so in that case any of the term may be negative. Okay, suppose we can consider that motor directions, rotation of directions may be different. Okay, so by that way you can distinguish that it is your second quadrant operations and it is your it's a regenerative braking conditions. Okay, like that means braking means it's, you can say like the motor behaves like a generator. Okay, so what are the different modes? The based on that you can, what you are that we are talking about that four quadrant operations of the chopper. I think in power electronics when you are when you gone through it, so you know the you know about it that four quadrant operations. Okay, how it will be performed. Okay, four quadrant operations of the chopper. Normally what we are doing, just for recap I am just telling you. So I know, I think all of you are aware about that full bridge converter. Okay, so full bridge converter means it's a like that there are a half bridge converter and full bridge converter. Okay, so two types of bridge converters are there. I am considering about non-isolated type full bridge converter. Okay, so in another word you can say like that it is also known as edge bridge inverter also. Okay, edge bridge inverter, but we are talking about bridge inverter. Okay, inverter means you can say like that output voltage is your alternating in nature. Okay, so this simulation I will do in our next year. I will show you that simulation how it will work. Okay, in your power electronics lab. Okay, so what happen in case of bridge converter? Suppose you know that the duty. Okay, duty means on time means T on by T. Okay, ratio between on time by total time period. Okay, so that we are talking about that alternating in nature. But what is the important thing? We are considering about our considering about the average value of that voltage, average value of that output voltage. Okay, what happen in case of full bridge converter, or you say like that four quadrant operations of the chopper? So you are varying the duty ratio. Suppose on time durations you are varying. So what is your output voltage V out equal to? So you will get that I am talking about that alternating there in nature, alternating voltage there in nature. Okay, so what will be the output voltage? So in average conditions, what will be the output voltage? So on time durations into V. Okay, so on time durations mean T on into V plus we are doing average. Okay, we are doing average plus off time duration means T off into another V, that will be negative V as they are in alternating in nature. So positive V is your on time durations. So negative V definitely it is your off time duration. Okay, as they are in alternating in nature. Okay, so what is your output? So V into T on plus within bracket minus V into T off. Okay, or you can say like that T on into V on. Okay, plus minus V off into T off whole divided by total time period, that is T. Okay, it is your V output, V average output. So based on your duty cycle, you can decide that what will be your voltage. Okay, that output voltage may be positive, may be negative. Okay, how do you decide? Based on the T on durations. Okay, that V minus V also be there. That magnitude also be there, as well as the durations of your on time durations as well as off time durations. Okay, that you are using that PWM. Okay, so PWM to your switching device. So based on that value, that your output voltage is changing. Okay, output voltage of your converter is changing. And suppose your motor is connected to the output of that converter, then automatically motor terminal voltage also changing. And by this way, we can decide that motor is operating in motoring conditions or plugging conditions. Okay, so plugging conditions means I think one subject was there. Okay, so that electric drives. Okay, I hope you gone through it in your curriculum. Am I right? Do you know? Do you go through that electric drives, Angshuman?
Yes, sir.
Yes, sir.
Okay, so four quadrant operation you already aware about it, so I'm not going to repeat them. So you can say like that it's a motoring mode. So plugging mode means entirely different. Okay, entirely different means you can change the terminals of the motor, but one important consideration, that field current direction should not be changed at any cost. Okay, so field, if you directly that magnetization's current of the field has been altered or has been changed or opposing as per your convention, then the field winding may be damaged. Okay, so that's why be very careful. So you have, in that case, you have to use some changeover switch. Okay, that also be there in your locomotive drives. Okay, those are doing the training on that vocation, means vocational training to there, so they can also see in the travel to the, they can also enter to the locomotive. Okay, loco that place of loco pilot. Okay, so place of loco pilot means where the loco pilots are sitting. So where one switch is there, when you are going to move your train in reverse direction, you have to pull that switch. Okay, suppose you know one thing, those are traveling in auto rickshaw. Okay, they can also see when auto rickshaw is going back, okay, backward directions. Before going back, they are using some changeover switch just below of your driver. Okay, driver, right now that auto rickshaw or self start operation is there, but around 5 years 6 years back it was not self start. So there is a one hand driven shaft was there just right side of that auto driver. So you just pull that on and your auto may be started. Right now that option is not obsoleted, but one switch is there just before of that handle, one switch is there. So before, if you want to go for the reverse directions of your auto, so you have to change over that switch. Okay, so field, basically that excitations of the field should not be altered. They are not like that, they are not changing that field of the changeover switch. Maybe some other mechanism will be there, so motor will be, maybe they are changing the terminal of the motor. Okay, so what motor is there, so motor will be coming rotating in reverse direction, that's why they are using changeover switch. Okay, but if it is DC motor, so changeover switch will be there, as well as changeover switch of your field also be required. Okay, so four quadrant operation. So we are talking about degenerative braking, means your motor speed, motor speed more than of your rated speed. Okay, shaft speed more than of your rated speed. So what happened, your generated EMF, okay, so that back EMF value, okay, will be more than of your terminal voltage value. Okay, so the direction of IA automatically changing. Okay, so if that zero crossing, so when the direction of current is changing, at that moment your field winding terminal also will change. Okay, so dynamic braking means you will replace, okay, you will replace that entire energy will be replaced, okay, will be dissipated through a resistive path. Okay, so you will replace that voltage, okay, so source voltage by a resistor. Okay, so you know that in motor, in traction, there is a shunting resistance. Okay, so that shunting resistance may be work in different manner. Suppose they can be used just like a additional resistance with your series with your armature. Okay, so it's a series motor, and that same resistance you are working for that dissipations of the energy. Okay, so stored energy inside of your motor, replacing that terminal voltage. So that's your dynamic braking. And plugging means your conditions are that I'm telling. So locomotives is going backward directions. Okay, so not forward directions, they want to go for backward direction, so you have to change the terminal of that motor. So it is called the plugging mode operations. And four quadrant operations, so both motor and torque you are controlling. Okay, suppose right now that lot of sophisticated drives are using. Okay, so instead of direct DC motor drives, you are using some AC motor drives and sophisticated applications, so directly you can do it. Okay, so forward mode of forward operations also very important. Okay, so motoring means the arrangement of the motoring shown in the figure. So here you can see from the figure, so it's your motoring conditions. Okay, motoring is there. Back EMF, back EMF EG means EG means back EMF. Okay, actually EG, why I mentioned EG, so it is your generated EMF, but actually it is generated back EMF. Okay, is less than the supply voltage. Okay, that is VY. Okay, VA, so both armature and the field current are positive. Okay, the motor develops torque to meet the load demand. Okay, so motor develop the load demand. So if you can recall the four quadrant operations of your four quadrant operations in your electric drives. Okay, that book, if you recall that conditions, four conditions were there. Okay, when it was in motoring conditions, the genetic conditions. Okay, so one diagram was there. Okay, there is a pulley. Okay, pulley, then counter load and your motor load. So that four diagram was there. Okay, based on that, I think you are recalling that conditions. Okay, so so which one is goes to the tends to the equilibrium points. Okay, which tends to the which condition retain the equilibrium point. So you can say like that, steady state equilibrium. Okay, some load torque equal to motor torque, some derivations also be there. Okay, I hope you are recalling all those things. Basically, utilization is an one kinds of informative subject, but it touch different electrical engineering subjects. Suppose drives, especially we are talking about drives, power electronics. Okay, basically for the traction. Okay, when we are going for illumination, some different types of thing will be there, different definitions will be there. Okay, so some numerical problems will be there. Okay, then heating, welding, another some new type of informations you can you are known to money, you can get some idea from it. So basically the subject cover practical applications of that electrical engineering in different fields. Okay, some generalized way. It's not like that it is limited to this type of content. Lot of other additional contents also be there, but we are talking about some conventional contents. Okay, so from where we are easily able to grab the basic idea. So when you will join, join as a graduate trainee, at that time you can cope up with that situations, and you are in uplift yourself as per the required technology or as per the demand technology to your to your organizations or industry. Okay, so that's why some basic idea we should provide to us. That's why the subject is very important for all of the students. Okay, so now we are talking about the regenerative braking. So you are all aware about the regenerative braking. Still, I recap some of the portions. The arrangement of the regenerative braking is given in the figure. So you can see the it's your separately excited motor, but we are concerned about the series motor. Okay, so you can see for the regenerative braking, the changeover switch is there. Okay, so when normal motoring condition is there, so F1 directly connected to the armature positive term, positive voltage, positive terminal of your source, that F1, and F2 will be connected to the load directly, armature terminal. But at the condition of regenerative braking, so changeover switch is there. So F1 is connected to your armature and F2 is connected to the positive terminal of your voltage source. Why? To maintaining the current direction same. Okay. So otherwise, first case that current is flowing from F1 to F2. And second case for regenerative braking condition, you can see current flowing to the same direction, F1 to F1 to F2. Okay, the arrangement for the regenerative braking is given in the figure. The motor acts as a generator and develops an induced voltage, that is EG. So you can see the generated voltage, it is your EG. Okay, and it's your motor. Here you can see EG must be greater than the supply voltage, that is VA. So motor voltage, you know that voltage, terminal voltage, that is your VA. We are giving more concern about the series motor. Okay, so the armature current is negative. Okay, why current is negative means the direction of the current is reversed. So what, before starting of this content, I told you that whatever conventions or whatever reference you are considered, that is your convention. Okay, suppose positive you are considering for current is flowing from inside of the armature, so you are considering that is positive. So reverse current, you are getting the reverse direction current, so you can say like that current is negative. The kinetic energy of the motor required to the supply, so you have to give the supply to the kinetic motor. Okay, a series motor is usually connected as a self-excited generator. So self-excited, why, you know that separately excited, difference between separately excited generator and self-excited generator. So what are the difference? Difference is that it can excite its field by your own generated energy. Okay, so for the self-excitation, it is necessary that the field current field current aids the residual flux. So field current is also uplift the residual flux. So reverse direction is not possible. So it's normally accomplished by reversing the armature terminals or the field terminals. So when the current is goes to the reverse direction, so one relay will be there that can give a signal. Okay, and due to that relay circuit, okay, automatically the terminal will be changed, just like your zero crossing detector. Okay, in your washing machine, you know, like that machine, there is a motor, okay, that is rotating. Suppose some of the time duration it is rotating in positive half. Okay, then time complete. Okay, again it will be rotating in reverse direction. Okay, so zero crossing detector will be there. Okay. So then we are discussing about the dynamic braking for our system. So what is our dynamic braking? So you are changing, you are replacing that source by a shunting resistance. Some additional resistance is there, so you are directly connect with them, replacing that value. Okay. So again, in these conditions also the direction of current will be reversed as per the conditions of your motoring. So motoring condition, you are considering current is positive, and any other conditions, so it may be regenerative conditions, it may be dynamic braking condition, or it may be the plugging conditions. Okay, the current directions may be reverse one. That's why you can say like that it is braking conditions. Okay, so again the changeover switch is there, so current additional energy is passing through that additional resistance. Okay, so the arrangement is shown in the figure are similar to those of the regenerative braking, except the supply voltage VA is replaced by a braking resistance, that is regenerative braking resistance RB. and the kinetic energy of the motor is dissipated through that RB. Okay, it is the direct diagram is given for that dynamic braking or the resistive braking. Okay. Then for the plugging conditions, here you can see for the plugging conditions, terminals may be changed. Okay, which terminals? You are changing the armature terminal. So if you for two conditions also be there. So you can changes the voltage terminal also. Okay, but why you are changing the armature terminal? You are changing the armature terminal for what? So you need not to change the field terminal. Okay, the field terminal is fixed. Okay, so you need not to change the field terminal. That's why directly you are changing the armature terminal. Okay, in that plugging condition. So motor will be rotating in reverse direction. So current is in same direction. Okay, so for the motoring conditions. Okay, more current was from source to motor side. You say like the source to load. Here you can also see the current is flowing from source to load. Okay, direction of the current. But motor terminal you have reverse. Okay, so plugging is a type of braking. The connections of the plugging are shown in the figure. So here you can see the armature terminal are reversed while it is running. Okay, the supply voltage VA and the induced voltage EG. Okay, EG is your induced voltage. Okay, at the same directions. Okay, supply voltage and EG. Basically, what happened normally? Why we are talking about back EMF? So, what is the reason for the back EMF? So, it is countering. So, it's your effect. First, in case of motor, you are giving the supply. After giving the supply, armature is there, current is flowing through the armature. Okay, so who is the cause? Armature current is the cause for generating that back EMF. Okay, why? The current is flowing through that armature coil or armature conductor. So current is flowing means it can cause, okay, it can cause some or it can develop some field. Okay, sorry, it can develop some magnetic field. Okay, and already that if your the magnetic field of your machine already energized by the source. Okay, that field winding is there. Okay, so current is going there through one field and current is magnetized the field as well as the current is flowing through that armature winding. So if the current is flowing through the armature winding, automatically some field will be developed. Okay, so field will be developed means magnetic field will be developed. So that magnetic field and the field winding magnetic field both are interacting. Okay, and you will get some resultant flux. Okay, so resultant flux or resultant field. So that resultant field is forced to rotate the armature of that DC motor. Okay, in the directions. Okay, so it can, you know, that there is a cancellation of field. So some of the field points are highly concentrated with the magnetic field. Some of the portions are cancelling each other. So there is a inequilibrium. So there's a one portion is trying to move, another okay, the flux density is less some of the portion flux density is high. So it try to move from higher density to lower density. So that may cause for the development of the torque. Okay, and due to torque, your total armature winding is rotating. Basically, your armature is rotating. Now you know that armature winding are grooved inside of your armature and it will be settled down over there. Okay, and your armature winding is rotating inside of the magnetic field, and due to that rotation cutoff flux will be there, and cutoff flux means in dphi dt that may cause what induced EMF. So who is the cause is armature current, and who is the effect is your induced EMF. So cause definitely countering with your effect. So that's why back EMF polarity is always reverse polarity of your armature current. But in case of plugging, what happens? You are directly changing the terminal. Okay, motor is rotating fast. Then what you will do? Suddenly you are changing the terminal. Okay, armature terminal. Then instantaneously what happened? For this condition that back EMF direction and armature current direction both will be the same direction. Instantaneously that polarity has not been changed. Why? Basically they are in inductive in nature. Okay, so in that concept of circuit theory, so they try to store that energy. So directly you cannot change their polarity. So that current direction polarity and that back EMF direction polarity, both will be same. Okay, so that's the thing happened in the plugging, and after getting some time, again it will be rotating in reverse direction. So at that condition, again the direction of the mechanism may be changed. Okay, the armature current is reverse. Okay, the armature current is reverse, thereby the producing the braking torque. Okay, so both are countering polarity. Now gradually it may cause for reducing the armature current. Okay, that EMF may cause for reducing the armature current. So gradually the current goes to zero. Then again it will start rotating in reverse direction. Okay, that's why it is called that plugging. So that current, that braking torque, and you will get the braking torque, and the field current is positive. For the series motor, either the armature terminal or the field terminal should be reversed, but not both. If you reverse both, then what happens? So again it will rotating just like a motoring conditions. Okay, so any of them should be changed. Okay, if you change both of them, so again it will be like a motor. I hope you are getting my points. Okay, you are facing any difficulties, any confusion, please let me know. Again, I will discuss. Okay, so plugging operation, I think you are able to understand. Now we are going to discuss about four quadrant operations. Okay, so four quadrant operations means here you can see four quadrant operation. So figures, which figures? You can see that four quadrant operation, the figure. Okay, so if you are not able to recall that portion, again you can open your drives book and please go through that portions. Four quadrant operations is very important for any aspects. Suppose while we are discussing such a manner, basically you are right now you are in pre-final year, so you have to develop yourself for your campus interview. Okay, so campus interview is not like the only we are doing aptitude, only doing some basic electrical portions like that, different components. Some for I am talking about the core subjects. Okay, core companies. Okay, so they can ask you in any of the aspects. Okay, so whatever content you are touching these subjects in utilizations, related subjects should be recap. You should do the recap. So when you will be in final year, at that time you will not get more time, and you are almost in verge of final year. Okay, so and the coming summer is very important for your career enhancement. Okay, if you have to recap all those things. So why you are waiting for that summer? So when I am going through that portion, that you should go through that specific content from any other book. Suppose right now I am discussing about the drives, DC drives. Okay, so my suggestion is that you should go and you can recap that portions if you are not able to recap all those things. Okay, some of you are did very good. Okay, some of you are not able to recap that portion, so please go through it. So if you facing any kinds of difficulties related to that content, you can ask me. Okay, so I can again rediscuss all those portions. Okay, so related to the drives also, no problem from my end. Okay, so my suggestion is that please go through that portion that I am talking about, that counter weight, balance weight. Okay, so torque is countering, how the load torque is countering your motor torque, then verge of equilibrium. So that portion you just recap it. It's required. Okay, very important topic. So here we can see the pictorial observations of your four quadrant operations of that motor. Okay, so four quadrant operations of motor also related to the four quadrant operation of the chopper, as you are changing the terminal voltage by the duty cycle of the chopper. Okay, so that's why both are correlated. Okay, it's not like that both are different topic. No, both are correlated. What is requirement you are, what kinds of requirement you are getting from your system, that instruction is giving to the that instruction is passing through your microcontroller. Okay, and microcontroller, the basic controller or compensator. Okay, you know that control system engineering that you are discussing about PI controller, P controller, PID controller, lead, lead, lag. Lot of classical controller we have done. So okay, that will be embedded with your that controllers are embedded with your microcontroller board. Okay, so what kinds of signal you are getting? Okay, you have to scale down the signal through the sensor. Okay, so that signal is coming from you are sensing that value and coming inside that it will be inserted to your microcontroller board or DSP board through ADC converter. ADC means analog to digital converter. Now you are processing the signal, means what is your threshold value and what actual signal you are getting. Now we are comparing them. Some error signal will be developed. Okay, and that error signal will be again compared with some repeating sequence. Okay, means some square sawtooth waveform or triangular waveform, and end of the day you will get some PWM, and that PWM coming from your digital platform to your analog platform by a digital to analog converter, DAC converter. Okay, so again some gains are required. Okay, so some driver circuit is required. That PWM feed to that four quadrant operation. We are talking about four quadrant operation of the chopper. So power converters of that chopper circuit. And based on that pulse width, okay, the chopper means switches of the choppers are turn on and turn off. Okay, based on their turn off and turn on duration, your output voltage will be different. That output voltage alternating there in nature, but you will get some DC kind of output voltage as duty weighted. Okay, high frequency alternating. So it's look like a DC approximately when you are getting average. Okay, that output voltage is fed to the motor. Okay, that series motor, or we are talking about series motor, that VA, that voltage is here actually VA. Okay, so motor speed, you are getting that motor speed, sensing that one based on the positions, everything you change, you will get that one. Okay, figure shows the polarities. Okay, figure shows the polarities of the supply voltage, that VA, back EMF EG, and the armature current IA for the separately excited motor. Okay, so here you can see forward motoring. In forward motoring conditions, that VA definitely greater than of your EG and current IA will always be positive. That we are talking about speed torque characteristics. Now you can see x-axis is your torque and y-axis is your speed. So both are in positive in first half. Means first quadrant. Second quadrant, torque is negative, speed is positive. Okay, so it is in generating conditions, means it is called forward braking conditions. Okay, third quadrant, what happened? It is forward motoring, just reversing also happen. It is called reverse motoring. Both speed and torque are negative in third quadrant, but you know their multiplication. Torque into speed is your power. Power is positive. First quadrant the power is positive. The third quadrant also power is positive. Second quadrant power is negative. Fourth quadrant power also negative. Okay, so fourth quadrant, yes, power also negative. Okay, so here you can see for the second quadrant order, your VA less than your EV, so degenerative braking happened. Okay, EG is greater than VA and IA direction is reverse than your motoring directions, motoring conditions. In your reverse motoring mode, IA also be reverse. Okay, but mod of VA will be greater than of your mod of EG. That I am talking here. No modular values are there. Mods are not there. But here you are using the mod. Okay, your EG you can see the reverse polarity. Okay, minus plus. Similar thing, you are just changing the terminal voltage. Okay, VA. The terminal voltage you are changing. In reverse braking condition, what you will do? The motor current is same. Okay, like your first quadrant current, armature current is same. Okay, so armature current is same, but which one is reverse? Your motor terminals are reverse and EG also in reverse. Okay, so generated voltage. So mod A less than of your mod EG. Okay, I hope you are able to understand. So here you can just in what it is written. Okay, figure shows the polarity of the supply voltage VA, back EMF EG, and the armature current IA for the separately excited motor. Okay, so in forward motoring conditions, means quadrant on one operations, VA, EG, and IA all are positive. That I am talking about it. Torque and speed also the positive in this quadrant. During forward braking condition, means quadrant 2, it is actually regenerative braking. Okay, so motor runs in the forward directions. Okay, and the induced EMF EG continues to the positive. Here you can see that that is more than your VT, actually VA. EG is more than your VA. So torque to be the negative and the direction of energy flow is reverse. The armature current must be the negative. Okay, supply voltage VA should be kept as the less than of your EG. Okay. Then reverse motoring conditions. Okay, in reverse motoring condition, quadrant 3 operation, VA, EG, and IA all are negative. Okay, so all are negative. The torque and the speed are also negative in this quadrant. Okay, to keep the torque negative and the energy flow from the source to the motor, the back EMF EG must specify. Okay, sorry, must satisfy the conditions mod of VA greater than mod of EG. The polarity of EG can be reversed by changing the directions of the field current or the reversing the armature terminal. Okay, and durations of the reverse braking. Okay, first one is forward motoring, second one is that forward braking, third quadrant is your reverse motoring, fourth quadrant is your reverse braking. Okay, means quadrant 4. Actually, in plugging happened in quadrant 4 and that quadrant 3. Okay, motor runs in the reverse directions. VA and EG continue to be negative, for the torque to be positive and the energy to flow from the motor to be source. To the source, the armature current must be positive. Induced EMF EG must be satisfy the conditions mod of VA get less than mod of EG. Okay, so I hope all of you able to understand. So 4 quadrant operations. So in my next class, I will start with that single phase drives, how it will work. Okay, so if you have any confusion, you can ask me. Is there any confusion from your end? Okay, so I think you don't have some